Hello and welcome back. We have understood that one versus all algorithm can be used with the algorithms which are capable of handling huge volumes of data. The example for the algorithm which can handle huge volumes of data is SGD classifier. For SGD classifier, scikit-learn will use one versus all algorithm and make the multi-class classification problems solved. When the algorithm is incapable of handling huge volumes of data, we should be using one versus one algorithm. So how one versus one algorithm can can make the algorithms like SVM to handle multi-class classification is by taking the subsets of data. When you use one versus one algorithm, it will take only the data belonging to the classes we are trying to build classifier for. Let us try to understand it in a detailed way. So when you use one versus one algorithm, it is going to build k into k minus 1 by 2 binary class classifiers, where k is the number of classes. For the digit recognizer, k is 10 because there are 10 classes there in the target variable. So it's going to build 10 into 10 minus 1 by 2, that is 45. 45 binary class classifiers with only data belonging to pair of classes. That's nothing but if you take that digit recognizer data set, it is going to take the records belonging to 0 and 1, build a model, binary class classifier between 0 and 1. It is going to take 0 and 2, build a model, right? So we have 4000 records belonging to each class there. And if you have to build one versus all, you need to take 42,000 records and build the model, right? Zeros 4,000 and rest 36,000 belonging to others, right? That is one versus all. But SVM kind of algorithms cannot handle huge volumes of data. So what one versus one will do is it takes the records belonging to 0 and 1, builds a binary class classifier. 0 and 2 builds a binary class classifier. So what's happening, instead of 40,000 records, it is taking 8,000, 8,000, 8,000 at once and then building the models and trying to find out the probabilities and consolidate the probability and find each class's probability. So that is at a high level. We'll see in detail with a small example. So k into k minus 1 by 2 number of binary class classifiers with only data belonging to pair of classes. Less data while training. That's the advantage of one versus one. The algorithm is incapable of handling huge volumes of data. This is best suit there. So the advantage here is to build the binary class classifier, the data is less, so computation is less, and the algorithms, many algorithms which are incapable also can be used to do multi-class classification. The disadvantage is too many classifiers you need to build. In one versus all, we built 10 binary class classifiers, but in one versus one, we have to build 45 classifiers for the digit recognizer dataset because 10 classes are there. And if you take a simple example, we'll be able to understand it better. So let us take that same data set with triangles, circles and rectangles as the target variable. Right? The three classes are there with 12 records. If you have to build one versus one, use one versus one algorithm, you will be building three models there because 3 into 3 minus 1 by 2, k into k minus 1 by 2. Three classes, 3 into 3 minus 1 by 2. Three models we need to build. What are those models? Triangle versus circle, triangle versus rectangle, circle versus rectangle. And use these three models and then predict probability for triangle, predict probability for rectangle, predict probability for circle for each record. So when you ultimately do the prediction or multi-class classification, you will get three probabilities because three classes are there. Triangle probability, rectangle probability and circle probability. Whichever is high, the record belongs to that particular class. So probability T is the triangle probability, PC is the circle probability, PR is the rectangle probability. Let us try to look at a pictorial representation of what theory we have learned so far. So here we are trying to build triangle probabilities. So we need to take triangle versus circle, build triangle versus circle and triangle versus rectangle, binary class classifiers. In one versus one, we will take the records belonging to only those classes for which we are building binary classifier, right? So triangle versus circle. So there will be 8 records only. Originally there were 12 records. We eliminated rectangle because we are trying to build a binary classifier for triangle versus circle. And we built a binary classifier. Again, triangle versus rectangle, we eliminated circle records. We have got 8 records only. So dataset size reduced and the algorithm will be able to handle less data. So we built a binary classifier. And then circle versus triangle. Again, we have taken records belonging to triangle and circle only, no rectangle. No need to build a model here because we already built a model for triangle versus circle. And when we built model here, we gave triangle 1 and circle 0. The flags, we converted triangle to 1 and circle to 0. On the circle versus triangle, you may be giving circle 1 and triangle 0. Right, the y variable is going to have either true or false or 0 or 1, right? So if you flip the labels, you can actually take 1 minus of whatever probability we calculated on the triangle versus circle. The PTC is the probability of triangle versus circle and PCT is equal to 1 minus PTC. So circle versus triangle probability, we can get it because we already built a model for probability to calculate probability for triangle and circle. And circle versus rectangle. So you need to take only data belonging to circle and rectangle and build a model. You get a probability of circle rectangle, CR. And for the rest of the two pairs also, you no need to build models because rectangle versus triangle, you need to calculate. So you will give rectangle 1 and triangle 0. But previously, we have built a triangle versus rectangle where we gave triangle 1 and rectangle 0. So you can take 1 minus PTR to calculate 1 minus to calculate TRT. Right? Just the labels flipped, so the probability will actually flip. I think you can understand. You need to think a little bit and understand. Here, no need to calculate the probability for rectangle versus circle because we already calculated the probability for circle versus rectangle here, right? In this previous slide, circle versus rectangle, and we gave circle 1 and rectangle 0. On the rectangle versus circle, we are giving rectangle 1 and circle 0. So we can take 1 minus CR. So we have got 6 probabilities now, right? For triangle 2 probabilities, for rectangle 2 probabilities and circle 2 probabilities. We need to normalize these probabilities to find out the probability for triangle, probability for circle and probability for rectangle. If you look at this, it is going to be probability of triangle plus triangle circle plus triangle rectangle divided by all probabilities. So why we are doing this is, we need to get the total probability, probability for triangle, probability for circle and probability for rectangle is equal to 1. For each record you are going to get 3 probabilities. If you sum all 3 probabilities, you should get 1. Right? So whichever probability is high, the record belongs to that particular class. This is how the 1 versus 1 versus 1 classifier works. If you look at the code, it is very simple. There is 1 versus 1 classifier in multi-class, and you need to pass the classifier there. We still not covered SVM classifier, SVC, so we are using SGD classifier only. And then you need to say fit and pass xtrain and ytrain, and then make prediction. It will predict. If you try to look at the estimators, it actually built 45 estimators because k into k minus 1 by 2 number of classifiers are KC2 classifiers. So there are k number of classes, KC2 classifiers, right? But combinations. So it will take combinations, and if the particular combination is missing, right, it will take flip and take minus, negative, whatever we have seen. And then the decision function, ultimately it calculates 10 probabilities. How will it calculate? It normalizes. Right? We have seen it clearly on the PPT, right? So even probabilities it calculates, only 10 probabilities it will give. Whichever number is high, the record belongs to that particular class. So that's how the 1 versus 1 classifier works. And before we conclude, 1 versus all is used when algorithm is capable of handling huge volumes of data. 1 versus 1 is used when algorithm is incapable of handling huge volumes of data. Scikit-learn will handle which algorithm, which 1 versus 1 or 1 versus all to use dynamically, no need to be worried about. But for interview purposes and in research point of view, if you are trying to build a new classifier, then this may be useful. Thank you.